Hi guys, today we'll be discussing a question based on the concept of day's work. Day's work is a concept where a vessel is involved in steering a number of courses and steaming a number of different distances. And then the objective of this question is to find the resultant course and distance she made good. Alright, so here a lot of numbers are involved and some students get confused with about it, but I'll show you hopefully a simple way of doing it. Already, there are two ways of doing this question. One of the ways is using the traverse tables that you get from the Norie's almanac or the Norie's tables. The Norie's tables has traverse tables from which you can get this information. The other way is using your scientific calculator, and I try to use a scientific calculator because times are changing. Students no longer carry those heavy books if they don't have to, and all of us have scientific calculators. So I try to show the easier way. If you think traverse tables is easier for you, you can go with that as well. I'll probably make a video on that as well someday, but I'm trying to show you an easier way where you can just use a scientific calculator. Using both ways, whether you use traverse tables or use scientific calculator, you will get the same answer. It will hardly be any different. The difference will hardly be in decimals. So there's nothing wrong with using either or, whichever you find easier. But this video I'll show you the easier way using the scientific calculator. Hopefully that you will find easy. Alright, so I'll go into the question here. And the question says that the vessel sailed from a certain position, which is 2742 north and 17842 east, and it was doing 15 knots by engines. Alright, so the vessel speed was 15 knots. The vessel then steered 067 degrees compass course with a deviation of 3 degrees east for 10 hours. The course was then altered to 096 degrees compass, where deviation was 1 degree east, and this course was steered for 8 hours. Thereafter, she steered a course of 230 degrees compass with a deviation of 3 degrees west for another 6 hours. You also have to find the position arrived. This is the first thing that you have to find. If she experienced a current setting 3 to 4 degrees true at 2.5 knots throughout her transit. You also have to find the course made good and the distance made good with a variation of 7 degrees west throughout the passage. So you can see why students get confused. There's so many numbers here, so many courses, so many deviation, distances, hours of transit, and you have to find a few things as well. But if you break it down, if you just systematically break it down and compile the information, you will see it's very easy. It's not confusing at all. All right. So I hope that you find this method easy. So if you look at the question, you can see how I have made it into columns, and I've kind of segregated the information as was given to me. All right. So the first course is given here. So this is the first course. You can see this is the first course here, and the first course was 067 degrees. So you just go back to the question and you will realize that 067 degrees compass, and then I have put the deviation given to me 3 degrees east, and that gives me a magnetic course of 070 degrees magnetic. Why is that? Because the rule of thumb is, and I'll keep mentioning these here, so deviation east, compass is least. So that means if deviation is east, your compass course will be less than the magnetic course, and deviation west, compass will be the best. That means compass course will be more than the magnetic. Okay, so this is comparing to magnetic courses. Alright, so once you apply the deviation, you get a magnetic course. Then the variation has been given to you as 7 degrees west throughout. That's the last part of the question. Last sentence he says is 7 degrees west. So that variation can be used to calculate your true course. And that rule is variation west, magnetic west, and variation east is magnetic least. Now I'm sure some of you or most of you know this rule of thumbs, but I'm just mentioning it here. And this magnetic east or best is compared to the true course. So whenever you see the variation is west, you know that the magnetic course will be more than the true course. So you apply your variation. Here you apply the deviation, here you apply variation, and then you get your true course of 063 degrees. Once you get your true course, write it in the two-figure notation. So put a quadrant to it, assign a quadrant. If it's 063 degrees true, that means that you are in the northeast quadrant, north 63 degrees. Right? So you assign a quadrant. I'll tell you why that quadrant is important later on. Alright, and then you write down the distance. So the distance is 150 nautical miles. Now where did I get this distance of 150 nautical miles from? So this is because and I'll just make this here and then I'll erase all this. So how did I get a distance? Because the ship's speed was 15 knots given to me in the question. It's 15 knots, right? And we steered on this course for 10 hours. Distance equals speed into time, and that's why your distance here is 10 into 15, which is 150 nautical miles. Alright, so see in the question itself, it says that the vessel steered 067 degrees compass for 10 hours and she was doing a speed of 15 knots. So that's how I got my first column. Alright, so the reason I didn't work these out all out before because I wanted to show you how I got these values so that you guys don't get confused as to how I'm getting these values. Alright, so I'll erase all this so that I can work on the next column now. But pretty much it's the same thing. So if you have understood the first column, you will understand the second and the third column as well. Second column again, it says the vessel is 096 degrees compass. Your deviation was east. If your deviation is east, compass will be least. So your magnetic course is more than the compass course, and that's why. So I'm working on the second column now, by the way. If you guys didn't get it, this is the second column. 1 degrees east, so I got my magnetic course as 097 degrees magnetic here. Right? Then I applied my variation. Variation will be 7 degrees again because that's what the question says. It's 7 degrees west throughout. Variation west, magnetic is the best, just like before. And that's why my true course is 097 minus 7 degrees, which is 090 degrees true. Alright, 090 degrees means it's east. It's on a coast of easterly course of 090. Yes. And distance is this time 120 nautical miles. Why? Because I steamed on this course for 8 hours at a speed of 15 knots. Distance equals speed by time, which is 120 nautical miles. That's how I got my distance for the second column. Alright, taking the third column now, I'll erase this again so that you guys find it easy to follow me. And just let me know in the comments if there's something that you didn't understand. I've tried to make it easy for you here. Hopefully it's working. Alright, so I'll come back to the third column now, and the third column here says that the true course is, this is given to me in the question, that the vessel was steering 230 degrees compass with a deviation of 3 degrees west. Deviation west, compass is the best, so that's why I will apply add the deviation to my compass course to get my magnetic course. Subtract it to get my magnetic course. Alright, because with deviation west, compass is the best. Deviation east, compass was least. Alright, as you saw in the previous two columns. Here compass is best, so I will subtract it and I'll get my magnetic course. Variation is 7 degrees west. Variation west, magnetic is the best, so magnetic has to be more than the true. So I will subtract the deviation. So okay, this is a good way I can show it to you so you guys know what I did here. I'll add it here. Alright, I added the deviation here, I subtracted here, I added here again, and I subtracted here. Here I subtracted and then I subtracted again, and I got my true course as 220 degrees true. What is 220 degrees? Again, if I have to give it a quadrant, 220 degrees lies here between west and south. This is 40 degrees west, 220 is here, so that's why a quadrant becomes south 40 degrees west. So assigning the quadrants is important because that will help us determine the delat and the departure in the next stage of the question. Alright, so I got my quadrant as well for my true course, and then my distance is 90 nautical miles. Again, you know how I got this, because I steamed on this course for 6 hours as given to me in the question. I steamed on this course for 6 hours, and 6 times 15, which is my speed, so 6 hours of transit times 15 knots, this is my speed, gives me 90 nautical miles. That's how I got my distance from. Alright, so Hopefully this was simple for you to understand on how I classified this information in these tables or in these columns. It's not finished yet, so I'm just letting you catch up with me. And then finally I put in the current as well. There was a current that was setting 3 to 4 degrees throughout at 2.5 knots. So 3 to 4 degrees is north 36 degrees west. Yes, if you didn't understand how, I'll explain to you. This is north, this is 360, and this is west 270. This is 3 to 4 somewhere is here. That means it's north 36 degrees west. You are going 36 degrees from north towards west. And how did I get my 60 nautical miles that you see as a distance? Because the vessel was experiencing a constant current of 2.5 knots. 2.5 knots was throughout the transit of the vessel, and that transit is for 10 hours, and then 8 hours. I add 8 hours, 18, and 6 hours more. So times 10 hours plus 8 hours plus 6 hours, which is 24 hours. So 2.5 knots times 24 hours, which will give you 60 nautical miles. Alright, so where did I get my 10, 8 and 6? So the transit time here was 10 hours, here it was 8 hours, and here it was 6 hours. So the vessel has been transiting for 10 plus 8 plus 6, that is 24 hours, and experiencing a 2.5 knot current throughout this 24 hours. And that's why when you multiply 2.5 by 24, you get 60 nautical miles, and that's the distance the vessel must have done due to the effect of the current. Alright, so I'll continue with the question here. The next part of the question, you will put down the true course from above. So you see, you put down this course here, and you will put down the distances here. Alright, so you put the true course and the distance. So the first one was north 63 east and 150 nautical miles, and then you calculate your DLAT and your departure. How do you calculate DLAT? DLAT is calculated by multiplying distance times cos of course. So I will give you one example. So in the first case, you have DLAT equal to distance, which is 150 nautical miles, times cos of course, which is 63 degrees, and you will get 68.1. Why have I put it under north? Because I am on a northeasterly course. So I will put the DLAT under north, and I will put the departure under east, because this is a northeasterly course. How did I get my departure? My departure, as you can see here, my departure is distance times sine of course. So my departure in this case will be 150 times sine of 63, which is equal to 133.7. And this is east because I am on a northeasterly course. So that's how I get my DLAT and departure. I just use my scientific calculators, and I can get the DLAT and departure using this formula here in all the cases. So you can see that in all the cases, so in the first case it was north and east because I'm doing a northeasterly course. In the second case, the course will be 090. If you are not very sure what is the course here, it's 090 degrees because your due course is due east. Distance is 150 nautical miles, and there is no north or south component, there is only east component. That's why there is nothing in north and south, there is no DLAT. Straight away you calculate departure. Why? How do you do that? You will calculate departure equals distance, which is 120 nautical miles, times sine of 90, which is also 1. That's why your departure is 120 nautical miles east, because you are on a due east course, 090. Alright, similarly in the third row, you can see that the course is south 40 degrees west. You got south here and west here. That's why the DLAT that you calculate with this formula here below will be under south. DLAT will be calculated by 90 times cos of 40, and then departure will be west because you are again on a southwesterly course, so you are a westerly course, and you calculate it by multiplying 90 by sine of 90. Alright, 90 times sine of 90, sine of course, and then we have north 36 degrees west. Alright, so north 36 degrees, so departure is distance times sine of course, that's right. Alright, so and then you've got north 36 degrees west, distance is 60 nautical miles. Alright, and again distance of 60 nautical miles, 150, 120, 190 and 30. So this north 36 west is the current, right? And then because it's northwest, you will multiply 36 times the cos of 36 times distance to get the d lat, and it will be kept under the north column. And then of course sine of 36 times 60. I said sine of 90 before, isn't it? No, it was distance was 90, sine of 40 it will be anyway. So sine of 36 times 60 will give you the departure. Alright, so you can try out in your calculators and you will see the value here. So why I put it in the west column is because your last current was setting north 36 degrees west. Alright, so hope you understood. All I used was this formula for calculating d lat and this formula for calculating the departure. Put in the course angles here and get the distance here, and you should be able to find these same values. Make sure you put it on the right column. If you're doing a north course, you put it in the north column. If you're doing a south course, you put it on the south column. And similarly, if you're on an east course, you put the departure under east, and if you're doing a westerly course, you put the departure under west. Once you do that, just add the values under the column. So here you add 68.1 plus 48.5, which will give you 116.6. The second column, you have only 68.9, so you leave it at 68.9. Then departure 133.7 plus 120 will give you 253.7. And finally 57.9 plus 35.3 will give you 93.2. So your resultant d lat now here will be 116.6 north minus 68.9 south, which is 47.7 north. Why is it north? Because your north d lat is more, so that name comes here. Alright, similarly your resultant departure 253.7 east minus 93.2 west here, and you will get 160.5 minutes east. Why is it east? Because the east one is more. You take the name of the one which is larger. Alright, now you have your departure latitude given to you in the question as 27 degrees 12 minutes. So you see the first line itself, it says that the vessel departed from 2742 north, right? Here, 2742 north. So if you departed from 2742 north, why do I have 27 degrees 12 minutes north? That's not correct, is it? Either I've written wrong here or I've written wrong there. So I will assume I have written wrong in the question here, so I have to correct it. So if I correct it, and sorry again guys, maybe I should have corrected here. It should be 2712 here. Alright, so if it's 2712 there, better I continue with that 2712 here as well. Alright, that's your departure latitude. Then you found out your resultant d lat of 47.7 minutes, which is from here. Now there's so much going on here, I don't want to confuse you guys. Right, so where did I get my d lat from? So this d lat, resultant d lat, is here. This is my resultant d lat. Alright, now you see why students get confused. There's so much going on here. Sometimes even I get confused. So you've got your resultant d lat as 47.7 north. Now that means you're going north from the departure latitude, so your north latitude should be increasing. Alright, and that is why you will add your resultant d lat to your north latitude, because you are going north. Your resultant d lat is north, that means you are going north, so you have to add the d lat to your departure latitude, and then you get your arrived latitude as 27 degrees 59.7. Alright, then you calculate your mean lat. How you calculate your mean lat? Because they are both in the same hemisphere, 27 degrees and 12 minutes north plus 27 degrees and 59.7 minutes north. They are both in the same hemisphere. Just add the two and divide it by 2, and you will get your mean lat as 27 degrees 35.9 minutes north. It's not because both your arrived and departure latitude are in the north hemisphere. Use your mean lat value to calculate your d long using this formula here. D long equals departure by cos m lat, which is mean lat. Mean lat is also m lat. These are all plain sailing formulas. If you have done or plain sailing, or you've seen my videos on plain sailing, you can see all these videos are on based on these formulas are based on plain sailing. Put your departure value of 160.5. This is the resultant departure that you calculated above from here. You can see that, right? And then divided by cos of your mean lat that you have found here. You should be getting 181.1 minutes in your calculator. Convert it into degrees and minutes. How? If you divide 181 by 60, that will give you 3 degrees 01.1 minutes. So you are converting minutes into degrees and minutes. And this is east. Why? Because your resultant departure was east. This is from your resultant departure. Alright, that means the vessel went on a course of northeast, or the resultant course was northeast. So your departure longitude is 178.42 minutes east from above. If you see, 178.42 minutes east. In this case, I have written it correctly. And then your D long is 003 degrees 1.1 minutes east, right? So you will add it because you are going easterly. Your easterly longitude should increase. Now when you add it, what you see here is that your east longitude becomes 181 degrees 43.1 minutes east. But your longitude can never be more than 180 degrees. It can never be more than 180. So you will subtract it from 360 degrees and change the notation here. And this becomes 178 degrees 16.9. Alright, now if you didn't understand this, this is what has happened. So you are very close to the anti-meridian of 180 degrees. This is on the opposite side of the prime meridian of 000 degrees. So normally when we face the or when we look at a world map, we are actually looking at the longitude of 000 degrees. But on the other side of the earth, which is like a globe, it goes on to the other side. So east comes on your right hand side. Oh sorry, your left hand side, and east comes on your left hand side. This becomes your east normally, right? Normally if you are looking at 000 degrees meridian, then this your right hand side becomes east, right? This becomes east and this becomes west. But when you go to the other side of the prime meridian of 000, it's 180 degrees. Then of course, because the earth is a sphere, east and west change sides. So now what has happened is you are very close to the anti-meridian of your departure longitude was somewhere here of 178 degrees 42 minutes east, right? You went further easterly direction by 003 degrees 01.1 minutes, and that's why you crossed over the anti-meridian and went into the west longitude, and the west longitude here you arrived in 178 degrees 16.9 minutes west. This is what has happened conceptually. If you didn't understand the concept, then you just remember that whenever you see your longitude is more than 180, subtract it from 360 and change the notation from east to west or west to east, whichever is the case. Alright, then the last part of the question wants you to find out the resultant course, the course made good. Again, you can use the plain sailing formula of tan course equals departure by d lat. Put in the departure value, put in the d lat value. So where do you get your departure and d lat from? You can see that the departure and d lat is the resultant departure and d lat. Alright, this is the resultant departure and resultant d lat from above. Alright, you get 3.3648. Take the tan on the other side. Tan inverse of 3.648 gives you 73.4. Because we are talking about course, I will make it a round number of 73 degrees. If it's more than 0.5 or 0.6, then you could have made it 74, but this is less than 0.5, so 73.4. I'll just round it off to 73 degrees, and then you name it north 73 degrees east, because your resultant d lat was north and your resultant departure was east. North 73 east is also 073 degrees true, as you all know already. Alright, so north 73 degrees east is somewhere here, 073 degrees. So this is 073 degrees true. Finally, you calculate your resultant distance, or distance made good rather, by dividing d lat by cos of course. Course you have found out here 073. D lat you found out was the resultant d lat above. Put the values, you will straight off get the answer 163.1 nautical mile. Alright, so I hope I simplified this question of days work for you. If it was still confusing, just send me in comments and just write some comments to me, and I'll try to simplify this further. I thought that using a scientific calculator would be faster and easier for you to understand. With traverse tables also it's easy if you are used to it, but these days modern day education, we don't carry those heavy Norie's tables everywhere. At least I don't give it to my students. So feel free to use the scientific calculator. But nevertheless, even if you use the Norie's tables and the traverse tables, you should be getting the same answer, nearby the same answer. Alright, so if you didn't understand any part of this video, please write to me in comments. And thank you again to all my subscribers and people who watch my videos and send me feedback and comments. I really appreciate it from the bottom of my heart. I'll see you soon with another video.